Good morning. My name's Ian Drew. I'm Executive Vice President of ARM, and it is a great pleasure to talk to all of you today. Stand in front of you feeling very humbled. I'd like to talk to you today about the past 20 years, what's happening today, and how that's really going to change and evolve in the future. We've already heard a little bit from Sam and Warren about part of that being low power, some of that being partnership, and some of that being thought leadership as well. And for the next few minutes, I'd really like to talk to you about how we can all go and do this together. I first stood up in front of you about 7 years ago, and we talked about the future and how the future will be around the internet, how the Internet of Things would evolve, how tablets and phones would evolve. I'd like to go into how that's really come about now and how Korea's been part of that. I go back to 1990. 20 plus years ago, the internet was just starting. You could have tablets and phones and everything was digital. If you look at where we've come over the last 2 decades as an industry, we now have 6 billion connected devices on the internet, most of which have gone on the internet over the last 2 years. This whole revolution of phones and tablets has been driven not by one company, but a collection of companies changing the way in which technology is viewed and how this industry works. But more importantly, it's not just about the rich European, North American companies and people using the internet. The penetration of phones in emerging markets is very, very similar to that in Western Europe and North America. We have seen this huge revolution of how people communicate and change and exchange data. Companies like Facebook, companies like Baidu have seen the vast majority of their new users and data coming through on phones. And that is really being driven by what is happening in this community and partnership that ARM has put together with Korean companies and around the world. So we've seen a big difference and change of how things happen in an industry. It's taken 2 decades, but the next 2 decades will be equally as strong, and there's huge growth potential. If we look even over the last 5 years, what we call high-end smartphones or superphones have really started to come into the fore. These are your primary devices, not just for making phone calls, but for data usage. The last 5 years have seen phones which have become your personal devices. I hate people when they say they're carrying a PC and it's a laptop. The most personal device you have for you now is your phone. 2 years ago, 2% of the people had tablets. We're now seeing huge growth in the demand of tablets, not just iPads, but in the Android devices and other form factors as well. Graphics. We've seen a 20x improvement in graphics. I'll repeat that, 20x improvement in graphics. You are seeing console quality games, graphics on phones now, and all of this will continue to grow. The processor performance has gone up 15x. Some of this has come from dual and quad core, some of this has come about with processor improvements, but all of it has taken the same amount of power. We are still seeing battery life of all day being very, very important. All of this has been done in partnership, and it cannot be done by one company, and the differentiation the ARM ecosystem brings is going to be huge in this. But this can't be done just by processing alone. You need to feed the machine, the tablet, the DTV with all of that data. and we've seen a 15x increase in data rates. You need to make sure you have connectivity, and the faster the connectivity, the more data is going to be consumed by the consumer. And with graphics performance, you need screen resolutions. We've seen a huge increase in screen resolutions. So the last 5 years have seen huge growth. But the most important thing has been the change in how people consume content. We have seen a big shift from PC being your primary compute engine to your laptop and your tablet and every other device that you have. It is always on, it is always with you, it is always connected. We have now seen this shift where mobile is driving the future of computing. We couldn't have thought about that 5 years ago. We dreamt about it. We are now at that crossroads where 6 billion people are using these devices and growing, and it is really a revolution that's happening around the world where people are taking different form factors and differentiating and growing and creating a trillion-dollar business on apps, on hardware, on software, on platforms. The Olympics in Beijing, people called it the first technology Olympics. We are lucky enough in London, and Samsung sponsored it, to have had the Olympics this year. Somewhere between 40 and 50% of all the people who viewed the Olympics, who were not at the Olympic Park, viewed it at some stage on a smartphone. Twitter, which only started a couple of years before the Beijing Olympics, there were more tweets on the first day of the Olympics than there were in the whole of the Beijing Olympics. And people weren't just tweeting about the Olympics, they were tweeting about what's going on and what's around the Olympics. The #1 tweet for the Olympics wasn't Usain Bolt, wasn't Mo Farah, was the Spice Girls at the closing ceremony. This is a new way in which technology and culture are starting to come together. People are looking at how they're using devices, and it's becoming everyday part of their life. That's why it's the most personal device that you have. That's why it's driving this huge consumption demand that we're seeing. Tablets. About 2% of people had them 2 to 3 years ago. This huge growth in tablets is driven by content and content distribution. It's much easier to consume content when it's in your hand, when it lasts you all day. Consumers started with this. We saw games, we saw internet access, we saw mail. But over the last year and heading into the next few years, a lot of companies are driving enterprise-level applications now. And we're seeing a 50% growth in tablets in the enterprise space. We think this will continue, and it will become the primary compute device, not just for consumers, but for enterprises. Bring your own device to work. Another enterprise application. CIOs around the world are going, we won't just let you have an IBM laptop now. Bring your own device into work. We'll let you go and do email. We'll let you go and access the SAP system. We'll let you go and access the back-end enterprise. We're now seeing 3 to 4 times the amount of devices connecting to enterprise networks. We're seeing people carrying 2 or 3 or 4 devices that access the internet, one using it at home, one on the road. You can now start structuring your day and around your travel and how you want to carry things and what you want to go and access, not by having one device fits all. This can only be done when you have low power, high performance, software that makes sense, and a compatibility running across multiple devices. You need the internet to run everywhere. You need to make sure it's secure. It's important that we have this going through all of our future. When you look at this year, and we sit down and we analyze what's gone on this year, there's a number of firsts. 40% of all smartphones ship with a dual-core processor now. A lot of those were designed and shipped and manufactured and built and thought about in Korea. We've seen the first quad-core processors shipping in volume. We've seen innovation coming out in new business models. We've seen energy-efficient devices in the Internet of Things. Huge leap forwards in how smart meters are put together, business models driven around data. We'll talk a bit about that later. But it's been driven by 50-cent processors that are coming to market. We have seen growth at the high end in servers, where the first server productions have happened. We're starting to see significant growth in the billions of units at the low end, and this huge partnership in between, enabling all of that seamlessly with the same set of software resources, going from a very low-end 50-cent microprocessor really through to the high-end servers. The first year that this has ever happened, the first architecture that's ever managed to get this done, and I think, and we think, this is a critical turning point for this industry. Very high-end servers, very low-end microcontrollers, quad-core, dual-core phones, and the rise of the tablet. This year has been fantastic for this industry, has been fantastic for this partnership. But the partnership can't just be around one company dictating. We now have over 1,000 companies in our connected community. 40% of those are in Asia, significant amount of those are in Korea. It is a critical way in which we start sharing information, connecting people together. Companies from automotive manufacturers, smart meters, all the way through to server manufacturers and software companies. This is not just about semiconductor companies, this is about connecting ecosystems together. OEMs talking to software partners. Application software companies talking to semiconductor companies. We see huge growth in this area, and we'd like to thank you all for taking part in the connected community. This week, we announced our first e-magazine. We used to ship lots of paper around the world. We've now started shipping our e-magazine around the world. And if you want to go and register for that, we can get you all the details for that. This is how we start connecting partners together and communicating on an ongoing basis. We think it's critical, and the way that the ARM community works around partnership is critical going forward. This word partnership we use a lot, and a lot of companies talk about it. But ARM for the last 22 years has realized that the growth of the partnership is the most important thing in this industry. That's why we keep feeding as much information and making it as viable as possible to differentiate and move between different products in the ARM range. For ARM, it's critical that we keep this differentiation alive and the partnership vibrant. I'd like to talk about Windows. One thing that we didn't talk about when we said how fantastic this year was Windows. Samsung's tablet is up there. We've now started seeing shipments of Windows RT. We're seeing this going into enterprise class. We're seeing it going into consumers. We think that this is a huge change for the industry. We'd like to thank Microsoft for that, but we'd also like to thank all the OEMs for support on this as well, because we see this as a big leap and a big step change in the industry, how things are done. Innovation. We talk a lot about innovation. We talk a lot about how the future can change. But we've seen that over the last 5 years, and we see how it's going to change in the future. One of the biggest questions I get when I sit down at almost every press conference is, which product do you think is going to be successful next? Which product should I design? Should I design something that looks like an Ultrabook? And my answer is always the same: I don't know. And the reason we don't know is because we think that differentiation is important, and letting people create multiple products across a huge range of opportunities and getting OEMs and the consumer to decide is really the right way forward. So we won't stand up here and say, we'd like you to all design this product. We think that you're much more imaginative than we are, much more creative than we are, and we think this innovation happens in the industry because we can produce some foundations of our architecture that go across multiple software standards. You can add features and differentiate and bring product to market significantly better than us. We've seen things like the Nest product in the middle here, where you can control your heating system and get 20 to 30% power efficiency, energy efficiency out of home heating. We've seen things like DTVs and creative DTVs where you connect to the internet and have new business models around downloading content. We think all of these will become important, and we think all of it will be driven by new and innovative ideas that will not just come from ARM, but from this partnership and ecosystem. This whole industry in the future will be a partnership industry. Without the partnership, you won't get this innovation. They go hand in hand together. The future, though, and this becomes very important on how we work together. The future really relies on a new economy. This new economy will be known as the data economy. And I'll explain to you how it works and how important this is moving forward. On the left-hand side, you see mobile computing and all the connectivity that we talked about. Billions of units there. Phones, TVs, tablets, screens, everything connected together. The connectivity growth over the next few years going from 1 to 10 to 20 exabytes of data a year, growing exponentially through consumer usage of new content, of video, etc. Then you get billions of devices connected to the internet, called the Internet of Things. Small devices with low power radio. They won't put out as much content per device, but when you multiply the billions of units, they will also grow the amount of content going across the internet. That data is very, very powerful, very important, and can be used for lots of new and innovative business models. The problem is as follows. That 10 to 20x growth in data, you can't scale the amount of power going into the infrastructure 20x. You need to make sure that your power doesn't scale with the amount of data going through the network. In fact, the goal should be to scale the data but keep the power flat through the infrastructure. Base stations, wireless, servers need to consume the same or less power now and in the future. Otherwise, we run the risk of moving all of that power saving from the tablets into the back end, into the servers, and you won't get economies of scale. The data business model needs to be driven by low power infrastructure. And this is where merging of this physical world and digital world would happen. So, one size does not fit all. We talked about the 19 90s. The laptop that I had in the 90s is exactly the same look and feel as the laptop I have now. We think that one size does not fit all in the consumer space. Phones look different, digital TVs look different. This diversity drives innovation. But the connectivity to the internet will be different. You will see 2G, 3G, 4G, Wi-Fi, Bluetooth, Zigbee. All of that will need differentiation. All of that will need different power supplies depending where you put it. And then when you go into the server space, you have multiple uses of servers as well. There is not one size fits all when it comes to servers. And we think that there is a huge change going to happen there as well. Your tablet, it may be 10 times more power efficient than your laptop. 10 times more power efficient, but you still want it to have all-day usage. And you still want it to be light, and you still want it to have the right battery capabilities. The base station, you need to have dispersed intelligence. You need to have intelligence at the edge of the network. If you're going to get 20x the data through a network, you need to make sure that edge of network device has all of the intelligence in it. And then the back-end data server, you need to make sure that you have all the capabilities there to sustain the correct power budget, because you cannot scale power with data. They do not scale linearly, and you need to be more power efficient there. The future will look different tomorrow than it does today. I'll repeat that. The definition of the future is it's going to be different than today. 3 billion people extra will come in over the next 20 years that will be able to buy phones, tablets, devices. This will be a new economy for them, and the difference will be they will expect 3G, 4G as a utility everywhere. The children that we have now expect the internet, expect wireless. That will continue to grow. We will still see demand for all the devices that we're looking at today. The global economy will grow, the global population will grow. But if you look at how the world is going to change, you're going to have 18 countries running shortage of water in the next 13 years. This is done by global warming. People are predicting a 4% growth. Some of that is coming from the technology that we design today. Data centers produce more CO2 than aeroplanes. Lighting, there is more electricity goes into lighting than is produced by nuclear power stations. We need to use our infrastructure differently if we don't want that 18 number to grow over the next 30 years. We need to make sure that we have low power, intelligent usages of our ecosystem to make sure the growth continues over the next few years. We can talk about that in a consumer space. We can talk about how low powering devices really changes the way that people consume data. But if people consume more data, it needs to be transmitted through a network. So we need to talk about how low power intelligent infrastructure works, both in base stations and in servers. Transportation and the rest of the industry take about 40% of the total power usage. We'll talk about motors in a bit. We'll talk about lighting. And then you need to talk about power generation. About 50% of all the power that's generated is lost in the network. We need to install intelligent devices in network, really to move forward with all of this. If we do all of that over the next 10 to 20 years, we may be able to become a lot more efficient with all of the devices that we use. We'll start talking a bit about servers. We've been very lucky in a number of system-level companies have announced servers with ARM. We've got the software in place now. We have the semiconductor guys in place. But more importantly, we have some of the data back. And if you were to really look at some of the data, what it shows you is you can get 70, 80, even 90% efficiency savings over the current infrastructure if you use an ARM-based core. ARM in the servers is going to happen. We're seeing trials now. We're seeing full deployments next year. We're seeing this huge growth in the server industry. The server industry has changed over the last 20 years. We've seen one big CPU core move on to the next big CPU core. We've seen virtualization come about, and we're seeing huge growth in power consumption. What you really want to do is move on to the green side of this, on the right-hand side, where we see multiple smaller CPUs that are much easier to control, are much more power efficient. And then moving on from that, multiple CPUs of different size with hardware accelerators, which bring even more efficiency to the network, even more efficiency to the servers. If you look at one server, it is not exactly the same as the next. Static web servers, dynamic, search engines, traditional online and offline analytics, all are within ARM's performance reach now. If you were to look at the next level of compute, an intense level of compute, we will get there with the 64-bit that we've just announced. We think that unique architectures and SoCs will be designed to meet all of these capabilities over the next few years in a significantly reduced power budget, in a significantly improved efficiency, in a performance window that will meet the data requirements moving forward. I/O and memory bandwidth will become important. We're working on both of those as well. And if you look at how data center workloads move forward, and these are real data from HP, HP is seeing scale out mainstream workloads and compute intensive workloads really starting to support some of the arguments from ARM. As the 64-bit architectures start to come out over the next couple of years, we will see a movement for ARM in this space that will see a dynamic shift, not just in the SoC world, but in power budgets and efficiencies and space and how data centers are defined and designed. We think that there is a huge opportunity to change the amount of energy consumed by all of this at the back end. We see this as a huge opportunity outside of the smartphone market for growth and competitive performance and differentiation. And to that end, we started a new group as part of the Lenaro activity. We announced Lenaro, a non-for-profit Linux organization that does kernels 2 to 3 years ago. We are now starting a group within inside of that that really starts working on servers and how servers are defined. And that group, the Lenaro Enterprise Group, has now been announced and started. And if you're really interested in how server market and software is defined, please start going to the lenaro.org, and they can give you a full update on how this works going forward. I want to change tack a little bit and talk about smart energy. I talked about lighting before. 19% of all the electricity consumed goes into lighting. We need to make sure that lighting is controlled a lot better. We've started working with a couple of companies on how to work efficient and effective street lighting. Intelligent street lighting, we believe, can cut down power usage in a city by 5 to 10%. We think that efficiencies in street lighting is important, and its intelligence put into each lamppost and communicating how this works really is important. On motors, we see huge opportunity to change the hundreds of millions of motors. Most motors have two modes, on or off. It's not that difficult. They were designed about 40 years ago. We see a huge opportunity to put microcontrollers next to each of those motors. Variable speed motors with intelligent control can save huge amounts of electricity moving forward. Heat in homes, intelligent heat in homes. That's also a big area. We're seeing thermostatically controlled, intelligent in-house networks starting to come out. Companies starting to work where they will reduce the heat in the house by 5% if nobody's there, and then as soon as they realize somebody's coming in, turn the heat back up intelligently. You don't need to have on or off on your heating control. It's very important that we work on all of these and not just one or two simple things. The thing that goes across all of this is low power. It needs to have an infrastructure of software put in place, and it needs to have reliability and security built in, all of which ARM and ARM partners know how to go and do. We're working with a number of companies, not just in an area of the microcontroller. It's how do you connect all of these together, and then how do you connect them into the cloud? We have seen a huge opportunity in low-power radios, 802.15, streaming data. How do you then go and put a lot of microcontrollers into buildings, get the data out, and get the data in an intelligent format that you can go and use, connecting this physical world to the digital world. We can't just have microcontrollers embedded. They need to be able to be there for 10, 15, 20 years and have data that really is able to go stream. We think there's a gap and a need in the market, not just for 802.15, not just for 3G, and we think moving forward they will start to combine, and we will see, click, low power radio technology in the TV white space coming out. Sub $2 radios, 10-year battery life, 5-mile range. We've become part of an industry consortium around this called the waitlist technology. We think that this is important going forward because microprocessors, very good. If they're not connected, they won't be used. We'd like to see that connectivity and that growth in that connectivity improve over time. The other problem that we see, once we fix the low power radios, once we fix the microcontrollers, is that each of these industries go, I'd like to put all the data together on my own. The motor industry, the medical industry, the lighting industry, all start to have data that's proprietary. And what's even worse, it's proprietary by country, and in some places it's proprietary by region, by country as well. So you can't share data. You can't amortize data, you don't know how it's fitting together, you can't personalize things. We think that there is a need, and a much stronger need moving forward, to have data across multiple industries, being able to be shared in the same format, being secure, because I may not want my medical records being on the internet, but I would like people to understand how to advertise to me are how I can improve efficiencies. So the biggest thing we see and the biggest opportunity we see moving forward is all of this data being personalized, but being used across multiple industries really to help the consumer improve their life. That's what we've called moving from the Internet of Silos to really the Internet of Things. And we've created an architectural forum which will really start to address some of these data proprietary usage models. And we look forward to having a lot more open discussion on this. The next 10 years will be driven by three things. It will be driven by billions of connected devices, phones, DTVs, tablets being driven in partnership with software that's unique, being targeted at consumers with lots of differentiation. There's still billions of those devices to go. There's trillions of Internet of Things devices that we can go and see. Those two sets of devices will drive information into the network. The power consumption of that network needs to stay where it is at the moment and not scale with data that's going to come from both of those. We think that's an opportunity and not a problem going forward. We think there's huge differentiation required in that. But we think there's only one way to go do this, and that's through a partnership model. One company cannot do this themselves. We need an industry really that is vibrant and growing around partnerships that are created over multiple years to go tackle some of these biggest problems around the world. If we don't do that, we end up with an industry that's fragmented and we never achieve critical mass of really what we want. We think there's opportunities in these consumer devices to be successful. We think there's huge opportunities in the Internet of Things, and we think there's great opportunity in the servers, the infrastructure, and if you were then to put them all together, we think there's huge opportunity in the data and the value of that data and how you analyze it, as long as it's done not in an Internet of Silos world, but in an Internet of Things world. With that, I'd like to thank you for coming today. I'd like to thank you for your patience. Thank you very much indeed.